All right, folks, what's up? I know this is totally ghetto, but I needed to get something online quick. So we're going to walk through a couple of different skills that we've been teaching you, starting off with Lewis dot structures. So get your periodic tables out. If you don't have them, then pause this because you can do that and go get your periodic table, okay? One of the trends that we noticed on the main group elements when you look at your periodic table is that we have this group over here are alkali metals. All of them that are in this column share similar characteristics. One of the things that they share is that they all have the same number of valence electrons, right? Which is 1. So you can draw Bohr's model of the atom for that, or you can take my word for it, or remember it from last unit. But here's how we do this. For Lewis dot structure, just look at the chemical symbol. For hydrogen, it's H, okay? And because hydrogen only has 1 valence electron, we represent the atom by drawing an H. This marker stinks. Let me find a better marker. I'll be right back. I'm back. We draw H for hydrogen, and that represents the nucleus. All the protons and all of the neutrons that are packaged in there. They're not a lot for hydrogen, but they're in there. So all we really care about are the electrons in the outermost energy level. For hydrogen, it's 1. So bam. That's dot structure for hydrogen. It's pretty simple, okay? Now, all of the elements that are in that first family, this group right here, the alkali metals, all have 1 valence electron. So lithium, the next one down, if you want to draw the Lewis dot structure for lithium, it's just the chemical symbol, which is Li, okay? And then you give it 1 valence electron. That's it. We're really only concerned with valence electrons, okay? The next the next group over here, the alkaline earth metals, these all right here, all have 2 valence electrons. So to draw Lewis dot structure for those, let's go ahead and do calcium. We just take a look at what the element symbol is, Ca for calcium, and we know it has 2 valence electrons. So we use Ca, capital C, lowercase a, to represent the nucleus, and then we just give it 1, 2 valence electrons, okay? What you'll notice for the main group elements, let me get out of your way here, your main group elements, as you jump across the transition metals and come over here to our boron group, our carbon group, our nitrogen group, our oxygen group, our halogens right here, and our noble gases right here, all of those increase by 1 valence electron with a maximum number of 8. So let me show you one real quick from our halogens. If we choose, let's go with fluorine. We talk about fluorine all the time. Fluorine, in that family, they all have 7 valence electrons. So, to represent the nucleus, all of those protons and all of those neutrons that are in there, we just draw a capital F, right? Which is the grade you don't want. All of them are in there. We just aren't concerned with them right now. We only want to know about the electrons in the outermost energy level. So 7 valence electrons, and watch how we draw them, okay? 1, 2, 3, 4, and then they begin to pair up the rest of the way around. 5, 6, and 7. Leaving a spot open for one more, which comes into play later, but this is now how we represent fluorine, okay? Only the noble gases, the ones on the far left-hand side of the periodic table over here, will have their outermost energy level completely full when you draw them. So neon, for example, has 8 valence electrons. We represent the nucleus of the atom like this, just that chemical symbol, and then we fill them in. 1, 2, 3, 4, and the second time around they'll pair up. 5, 6, 7, and 8. Okay? A maximum number of 8, or what we call an octet. That's the most number of valence electrons they can have. The only curveball to this is helium, really. Helium only has 2 electrons, but remember that first energy level can only hold 2. So helium belongs with the noble gases because it is stable, because that outermost energy level can only hold 2 electrons. So we draw the dot structure like that for helium. meaning that it is completely stable and completely full. And that's dot structure, people. Pause it, rewatch it, and then come see me for questions if you got it.